Multimodal learning analytics for examining coordination dynamics in mathematics. I think that's what we're expecting to talk about, so let's do it. Oh, actually, I'll say a very quick plug. This little T you see on various items that I have, my notebook and other things, that's from my lab. My lab is called Technological Innovations for Inclusive Learning and Teaching. And it sort of touches on these three areas that I'm going to sort of mention today, which are thinking about multimodal learning, so opportunities for students to work with their hands, use language, and use other modalities to engage in learning experience. Multiple interfaces, this really has more to do with, it's again about using different sorts of modalities, but really is developing ways so that the technology is sort of interpreting what's being said or what's being done using those different modalities, and I'll show you an example of that. And then the third area of my work is really multimodal learning analytics and trying to bring those things all together. So a lot of my work is really taking place in these sorts of contexts where you have a pair of students working together to solve a specific engineering design task. So this is actually work from my dissertation work where the students are asked to make something that can support a mass at a certain height above the table. So I'll show you this very quickly sped up video just to give you a sense of the context, to give you the sort of experience that students are having. They're using household materials, paper plates, sticks, straws, and so on and so forth, and to sort of work through completing this task. So yeah, that was just a very sped up version of the sorts of context that I end up working with. Students engineering and working together. There's language, there's other things that are going on in that, within that context. I'm going to talk through some of those a little bit later. But that's sort of the example of multimodal learning. And a lot of that is built based on, so I did my PhD with Paulo Blickstein, does work in Makerspaces and Fab Labs, and thinking about these multimodal learning contexts, so to speak. The next sort of work is around developing these multimodal interfaces. So this image here is of a platform called Tangicraft, which is a tangible interface for playing Minecraft. So what you essentially have is a number of physical blocks that students are building with, and then using computer vision in real time, you can essentially upload that design that they've created using physical blocks, and that will actually represent itself within the actual Minecraft game. And there's a number of affordances that come about when you now have a group of participants working around these sort of shared tangible objects, the sorts of conversation that happens there. And so this is one of the other areas that I work in, is developing these multiple interfaces. And I will say this was specifically designed thinking about ways for engaging students who have low or no vision in participating and engaging in really having an equitable experience within the Minecraft environment. Now, I have another interface. This is a natural language interface for playing Minecraft. Again, this was really designed for students who have fine motor impairments. So you have the opportunity to speak using natural language instructions into the game experience, and the game will then interpret those instructions and design or sort of build the thing that you've asked it to do. So I mention those because ultimately a lot of my work is thinking about setting up these different sorts of interfaces, these different sort of learning experiences, and then studying how it is that students are learning within those contexts, really looking at the interactions that are taking place within those spaces. So ultimately we sort of start with, oftentimes we start with a given theory. We start with a given set of ideas. We implement those within the interface, design a certain activity. We will put that into practice, and as that's put into practice, we collect data. And then once we collect data, we will then use different sort of analytic techniques to sort of think about how that relates back to the theory. And I have two arrows here because ultimately the way that we go about interpreting that data and making sense of that data is often very heavily influenced by the theoretical orientations that we're bringing about. So I mentioned those different examples just to sort of give you a context of where it is that I typically do work around multimodal learning analytics. It is around trying to study the different multimodal learning experiences and the different multimodal interfaces that students might engage with. But so the bulk of this is going to be on multimodal learning analytics. I'm going to sort of walk you through a number of different considerations in trying to analyze multimodal data. So first I'll just say, what is multimodal learning analytics? Several years ago, Paulo and I, we wrote a paper talking about learning analytics, which I sort of fundamentally saw as multimodal, that because learning is a sort of multimodal practice, the notion of having to say multimodal learning analytics seems somewhat redundant to me. But in fact, in thinking about multimodal, thinking about sort of the ways that learning analytics has been defined, intentionally putting multimodal in front of that has sort of been one of the things that we've had to do. But ultimately, I said learning analytics is a set of multimodal sensory inputs that can be used to predict, understand, and quantify student learning. And then later on in a workshop publication with Dor and several others, we sort of expanded on that idea to really think about the ways that multimodal learning analytics sits at the intersection of three ideas: multimodal teaching and learning, multimodal data, and computer-supported analysis. At its essence, MMLA utilizes and triangulates among non-traditional as well as traditional forms of data in order to characterize or model student learning in complex learning environments. However, as we describe later, the ways that researchers utilize multimodal data vary widely. And so some of those variations are things that I want to kind of talk through today. So I'm in the process of doing a literature review of all of the work around multimodal learning analytics that's taken place since about 2010, 2011. And sort of going through the last several years, these are the primary modalities that are coming up. Now, I identified a total of, I think, 379 publications that have mentioned sort of multimodal sensory data, multimodal learning analytics, or something along those lines. And these are just sort of the primary modalities that are coming about. So a lot of them are using video, 160. Large number are using audio, gesture, eye tracking, skin conductance, digital pen, and GPS and Bluetooth. Just to give you guys a sense of what some of these things are. And if people have questions around how some of these specifically are used that I don't get to, feel free to ask me later on. Because the next slide is going to be even more sort of overwhelming, which is to say, I've also sort of been tracking the different modality usage across the years. So, you know, the biggest thing to see from here is in 2012, you really only got like 6 different modalities that are mentioned within this body of literature. But as the years have progressed, you've really seen people start to add more and more modalities, more and more approaches that they're trying to use to analyze this data. And so, for me, this is exciting because it's, in many cases, these different modalities are becoming increasingly mainstream in the ways that they're being utilized. But you're seeing there's a whole number of things, getting into facial expressions, stress, eye contact, wrist movement, skeletal track, all sorts of things. But just to sort of give you a sense of the trend that within the general data mining community and within the general learning science and say, I'd say education research community, we're increasingly starting to see more and more of these modalities in use. So give you a sense of what some of these are. Eye tracking, this is one that you guys will all be familiar with because of the discussions that happened yesterday. I've pictured here 2 very low-cost eye trackers. iTribe, which was unfortunately sold to, bought by Facebook. So they're no longer selling their product, but this was sort of a revolutionary idea of having, you had a $100 eye tracker. So instead of having to pay what used to be $40,000 for an eye tracking system, you now had this low-cost eye tracker that made it a whole lot easier for researchers, practitioners, whoever, to be able to start thinking about using eye tracking within their data. Pictured off to the right here is the Tobii 4C, which is another relatively low-cost eye tracker. That one retails for about $150, $200, so still relatively low cost compared to, you think about the Tobii X2. Say that again? Which one is that? This is the Tobii 4C. Yeah, that's the Tobii 4C. They've got another one, which is the Tobii X, which is I think that's around the 120, 150 US. But the nice thing about Tobii 4C is that it does a better job of dealing with movement, dealing with head movement. So one of the challenges of working with kids is oftentimes, and I'll even say adults, you know, they're moving their head. And so to be able to account for that head movement in the sort of eye gaze predictions that you're coming up with. But these are sort of 2 of the low-cost tools that have recently come out. Another one that just really had a big impact on the market is this Empatic E4, which is a electrodermal activation wristband that essentially it measures skin conductance. And skin conductance has oftentimes been correlated with stress, with cognitive load, with arousal, with movement, with just excitement. And this is a neat device because in many cases it can sort of give you a window into something that would be hard for a human to perceive in watching a video, or even in perhaps even talking with a student. So it's giving us a window into the student's physiology and how they are sort of physiologically responding to a given experience that, as I said, would otherwise be very difficult to get. It also has heart rate variability monitoring, so you can get the sort of real-time heart rate information, as well as accelerometry data. And it connects over Bluetooth, so there's ways of sort of managing these devices. Challenge with this thing is, does anyone want to guess the retail price for one of these beautiful wristbands? Close, but keep going up. Yeah, so they retail for, I think, $2,000 or $2,200. The academic versions of them, when you buy them in bulk, you're talking maybe $1,400 to $1,600. And this is, thinking about this kind of device is going to come to a distinction that I'll hopefully get to later on, is thinking about multimodal learning analytics work that you're doing in a laboratory versus the work that you're doing in schools. I mean, you're not going to go to school and say, I want you guys to buy 500 of these things so we can put them on all the kids in your school. But these still do have pretty good utility for research, and as we try to develop different ideas within a laboratory conference. Dor, go ahead.
One size fits all?
In these, so interestingly, someone actually just did, and I'm currently reviewing a paper that someone used these on kindergartners. And they found that the heart rate variability did not work all that well, because the heart rate variability is basically, you've got a light on the back of it, and it's sort of detecting pulses that way. And so that part had somewhat of a struggle, but for the actual skin conductance piece, it worked fine. Go ahead, Dor.
You mentioned that it has an accelerometer in that, and presumably that's to capture some aspects of motion. Do you ever put it on both hands?
Normally you don't put it on both hands. Normally what you end up doing is putting it on a non-dominant hand. And one of the reasons why you actually want to have the accelerometer data is because skin conductance, or galvanic skin response, tends to correlate with movement. So someone who is moving more is likely to have a higher skin conductance. So one thing that you sometimes think about doing is to control, or sort of make sure that you're not assuming that someone is experiencing stress or arousal, when in fact they're really just having lots of movement. So this is a 4-channel EEG that I have some of these in my lab. I don't actually use them. The coolest thing about these is I've got a colleague who uses these to do drone races. So he'll actually put these on the kids, and they do an okay job of differentiating between moments of mind wandering versus sort of intense concentration. And the students have to use either moments of intense concentration to make it go like forward or back, or mind wandering to make it go left or right, or something like that. But these are, within the research, these are not, I wouldn't really say these are necessarily research grade, but they are sort of a low-cost device that people are utilizing to look at the sort of differences in mind wandering versus intense concentration. And with having only 4 channels on that, that's probably all you're going to get from it. This is an EMG. It's a device that you connect to your forearm, and essentially it's got electrodes on it that will detect when your sort of fingers are moving. So it's really detecting when the muscles in your forearm are firing. And it can sort of distinguish between the different muscles as they're firing. It's also got a gyroscopic sensor in it, and a few other pieces. I just got an email from this company, though. They're no longer manufacturing these.
Facebook bought them?
Yeah, it's something like that. They've moved on, but this was called the Mayo. This is one I've not used tons for research purposes, just in the sorts of the applications that I've had. It hasn't necessarily come up as being super beneficial, but it is, an example of another perhaps interesting device to use given the specific context that you're looking at. And the last one is going to be this digital pen. I will say too, the Maya was another sort of more of a low-cost device. It was around $200 per sensor. This is an equal digital pen. And the digital pen, essentially, it's a way for you to be able to capture a digital version of any writing that students is doing. Nice thing about the equal pen is you don't have to have a specialized book that you're writing with. So with something like a LiveScribe pen, you have to have the sort of specialized paper that they're writing on. With this one, it can work with any paper. There's essentially a little mount that I think this thing here is the mount, and essentially shines the light down and it's able to pick up where you're writing based on having this other device attached to the top of the piece of paper. So in thinking about instances where you may want to start to capture natural handwriting, but without having to have the students write on a tablet or having them write on specialized paper, the equal pen serves as a good way for doing that. So, there's a question of, okay, we get these different data sources, what do we do with them? And I put this up here to show that really within a single data source, there's tons of things you can actually do with it. And so for the example of audio, you can take a piece of audio, you can start to then distinguish between the non-speech components and the speech components. And even in the non-speech components, you can be listening for silence. You could actually be trying to pick up ambient noise that might be within the space. In the speech context, well, the first thing we oftentimes think about is you take that speech and you transcribe it into content, into words. And from that content, you can think about doing text mining. You can think about doing topic modeling. You can identify the type of utterance that's made. You can look at the complexity of the statement that's being made. You can look at things like disfluencies, when students are saying ums, because those are oftentimes correlated with a number of different things within psychology. You can look at the prosodic, so getting away from the specific text, you're listening to how they're saying things. You're listening to changes in pitch and changes in the frequency of the audio that's being utilized. Within, and this is something looking at the speaker, looking at who's talking, looking at speaking turns, looking at turn taking, and the amount of seeing how equitable the conversation might be. And there, you start to look at any number of factors. I mentioned social dominance as one. There's the spectral features that you can look at. There's issues of voice quality, of affect. There's a host of things that you can pull out from a single data source, so to speak. And so the first thing that we think about is we get all this data. What are we going to do with it? And this is where one of the complications arise. And this is in many cases where we start to try to ground some of our hypotheses into how we actually go about analyzing that data. What are the different pieces of data that we want to pick up? Which is, I'd say in a sense, it's more common to do within sort of education. More on the computer science side, I feel like oftentimes people get a data set, they will extract everything that they possibly can, pass it through a feature selection algorithm, and then move that way. But I think one of the neat distinctions that happens within a lot of the learning work is really people being very, very thoughtful about the features that they're pulling out. So I mentioned to you guys all those different features that you can pull out from that single audio source. There's also a host of different tools that you actually use to pull those things out of that given audio source. And so one of the things I'm working on now, which will hopefully be put into a written, shareable, publishable form within the next year, is really a chronicling of the various tools that are out there, the various tools that people are using, and essentially what are the different piece of data that you can actually pull out of those respective tools. Because there's a lot of them out there, and without knowledge of what's really out there, someone can spend a lot of time spinning their wheels in terms of figuring out where to go. And now here is just sort of a smattering. This is a part of this work I'm trying to do to sort of chronicle the different ways that people can, or the different things you can pull out from a given modality. The most interesting one is this one over here under other modalities. It's electrogastrography, which is the idea of looking at the stomach muscles and looking at how changes in one's stomach muscles or the actions and the ways that the muscles in your stomach are firing might correlate with different things as it relates to learning. Which is just to say that there's a lot of different centers out there. There's a lot of different modalities that people are looking at, but a lot of what we're trying to do is figure out how do these modalities matter for learning? How do they actually correlate and relate to the things that we care about studying? All right. Now, what do you do with all this data? I think that's the big question, right? In order to get a sense of that, I'm going to walk you guys through a study that I did. This is sort of the general outline of the study. Of course, there's a pre-test and post-test because those are tried and true, and that is, within the education research, that's what we know how to do. But in the middle, there's a number of other pieces. There's an actual intervention that students are doing. There's a design sketch that they're doing. There's a task that they're doing. And then there's also a reflection process. And part of my goal in doing this work is to really figure out how what happens in between pretest and post-test can help me better understand the correlations that I see between given intervention and those change in pretest and post-test. And so what I ended up doing was a study like the one that you guys saw at the beginning with the video where the students working on designing and building something. But I also wanted to prime the students and to have certain ways of thinking. And so in some of my previous work I looked at two different constructs. One is sort of example-based reasoning, the idea that students will look at an example structure. So for example, in this task of let me build something that's going to support a certain mass, a student might say, oh, a chair satisfies a similar objective. A chair, it is relatively stable, you can put a weight on it, and it can support it very well. And so in some instances, I prime students to use example-based reasoning. So I will say, think of exemplars that can motivate your design, or that you can sort of build off of. In other instances, though, what people do is they sort of build based on principles. They don't have a sort of a finished example in mind. They're really just saying, well, it needs to have a wide base. Triangles are strong. And they will essentially build those principles into their design and sort of put those together piecemeal. And so what I did was within the study, first I showed them these example objects, a bridge, a ladder, and an igloo. Then I gave them two different prompts. In one condition, I said, okay, I want you to think of personally meaningful objects that can also be examples that you can build off of. Think of something that you're very familiar with. Maybe it's a chair at home that you have. Maybe it's, I don't know, your house. In the other condition, I had them think about principles. I said, okay, I just showed you guys a bridge, a ladder, and an igloo. What is it about those things that make them stable? What is it about them that make them strong? And then I subsequently go on to study their process. The students worked in dyads. They had about 30 minutes. And, you know, these students are, it's a combination of undergraduate and high school students. So these students, so I ran a couple different studies with this. In this first case, I think I only had, what is this? This is showing 4 pairs. No, this is not true. I had actually had 10 pairs. But what I actually looked at was the rate of success based on the condition. And so what you're seeing simply here is that example-based reasoning, 1 out of the 5 pairs were successful. Principle-based reasoning, 3 out of the 5 pairs were successful. Then when you actually go rank the structures, one of the things I did, I measured the heights of the structures that they created. And when you rank the heights, you see that the 3 principle-based reason condition participants, their designs were essentially better, so to speak, than the example-based reason condition. So this is just to say there seemed to be something different about these 2 conditions. There seemed to be something that is noticeably different about the quality of their design. And then I also have this final graph that's sort of showing changes from pre-test to post-test in terms of the score that ended up coming up for them. And what you essentially see is that for the example-based reason condition, the students stayed relatively flat. But in the principle-based reason condition, the student scores increase from pre-test to design. So the question is, what's going on? How do I start to make sense of the differences between these groups in terms of process? And to do this, I had a Xbox Connect version 2. I did not yet have the Empatica. I had an old version of this called the Q-Sensor, and then I was using webcam data. Most of you guys are familiar with the Connect, yes? You said yeah? No? Or no? Okay, as a quick aside, if you are looking to do like multimodal data collection, and you want like a one-stop shop that has a lot of capabilities, the Xbox Connect version 2 might be very good for you. And that's because it'll capture gesture information. It can also capture facial expression, some amount of hand movement, and it also has a microphone array on it, which means it can give you directional audio. And so it can pick up versus if I'm talking over here or if I'm talking over on this side, it can sort of give me that angle that the audio is coming from. And if you guys want, I can point you to publications that talk more about the affordances of the Kinect in particular, but as a single device, that's actually a pretty good one, even though now Microsoft, because they've discontinued it, their researchers are even no longer using it, which creates something of a problem. So I have about 10 skeletal frames per second. for that connect data, as well as frontal images that I end up utilizing. I have an overhead camera getting about 30 frames per second and 16 kilohertz audio. And this is a quick aside. I know, and I don't know if you've used the OpenPose yet. Have you, Dor?
Not like that. We've done some motion capture through collaboration with UC Davis, but not this particular.
So it used to be that if you wanted to do skeletal tracking, you had to buy specialized hardware. You had to have the Xbox Kinect. You had to use the Intel depth camera. There's some recent work, and I say recent, probably came out around 2016, around using deep learning, essentially, to do skeletal tracking using just a standard web camera. So this is produced from just having a standard web camera. And from that information, you're able to get the sort of skeletal information for a vast number of people within a space. So I mentioned this. This is an open source tool that's out there. If you look up OpenPose, there's a library out there. And then there's a number of variants of that. There's also this thing called DeepPose. But all these are these open source tools that make it easier for you to collect the skeletal tracking information. The one challenge with these is that these are not analyzing data in terms of time series. So it's not resolving this person. It'll pick up the skeleton in this frame, then the next frame will pick up the skeleton again, but there's no resolution that this is the same person. It's not giving that information. That's something you have to deal with afterwards.
Is it tracking the joints? So we
Yes.
have coordinates of the joints.
It'll have coordinates of the joints. So this is a cool tool that's out there now that I'm using with some of my work. All right.
The time resolution?
The time resolution, well, I'll say that the processing speed depends on the quality of your CPU or GPU. So we're using that with the GPU now, but there's been a few versions that have come out that have even worked on like mobile phones, because they're essentially able to train sufficiently good neural nets to be able to actually handle the processing quickly. But it's highly dependent on your processing power. So that was a quick aside. So Empatica is getting 4 data samples per second, and so I've tried a few different approaches, right? So you have all this data, you're getting this high frequency data. What are you going to do with it? So the first thing I kind of do is looking at really just downsampling, reducing everything to sort of a single value across an entire session. And really aggregating over that entire session, which I could have sort of considered as sort of this naive fusion. So let's say this is my data. I have, at every second, I get a data point around audio, data point around gesture, and a data point around electrovertebral activation. And at the end of that, I basically just take the mean. I get mean values across all the different variables. Within my data set, this actually already starts to produce some interesting correlations. So I look at the frequency of gesture co-production during the intervention. So gesture co-production being 2 individuals, both sort of doing something with the material at the same time. And here you see that in terms of the example-based reason condition, it really hardly ever happened. In the principle-based reason condition, it happened about 40% of the time. So just to say that, this is one way of going about slicing your data. You could boil it down to these sorts of means across a different modality. Similarly, so I have a proportion of co-produced gestures during a building activity. Oh, and sorry, I should clarify. The other one was looking at the actual intervention, or the intervention phase. So when they were coming up with either example structures or mechanisms for their to explain why the example structures I provided were stable. I also looked at the co-production during the actual building activity. And again, you here see some sort of small differences. And then lastly, I'm looking at a single modality at a time and looking at the average seconds of speech during these sort of 30-second chunks. So let's say I break everything up into 30-second chunks. During how many of those chunks do I actually see, or during how much time on average do I actually see there being audio produced? So here you're essentially seeing that the principle-based reason condition, they seem to be participating in more verbal interaction with each other. So that's sort of one way. Looking at the sort of naive fusion where I take everything, all the data points, and mash them up into a single data point. The next thing I'm going to talk about, and this is probably where I've spent more of my time, is thinking about the sort of feature fusion, where the motivating idea is this work by David Hammer, where you start to characterize a student's, I'd say, multimodal behavior based on a combination of modalities. So you think about a student in a classroom, you can really, well, in this work, they sort of break them down into a few different frames. You have maybe one multimodal behavior where it is a student head up, very little gesticulation, very little movement, their eyes looking at the instructor, very little sort of conversation. So that's sort of one frame. You're sitting and listening. You have another frame where you're maybe heads down and you're maybe moving your arm a little bit, but you're not really talking. What you're doing is engaging with your material. Versus another frame where you're in a group discussion. Heads are up, there's a lot more movement that's going on, there's a lot more fluctuations in the audio, there's audio being generated. Which is just to say that what matters in this context is really the intersection of the different modalities. It's how those things relate to each other, the context that the lack of movement or what that means in relation to the other modalities. So the way that I end up doing this is, again, I start off with this. This is the sort of the raw data that I have. On a per second basis, I have this audio information, this gesture information, the skin conductance information. And what I really want to try to do is to break it down into these sort of canonical multimodal behaviors. And so in order to do that, what I'll do is look at sort of groups of these behaviors and then use a clustering algorithm to look at what seem to be the prototypical sets of multimodal behaviors that seem to co-occur with one another. And so thinking about Scott's talk yesterday, it's kind of like, how do you break down this complex sequence of actions into a representative set of common actions that all participants seem to take, that all participants seem to use, and then use that to re-represent each student's sort of stream of data, so to speak. And so in concrete terms, I ended up with these 4 different states. One of the states was really highly characterized by talking and not much skin conductance. One was characterized by very low levels of all 3. Another one was characterized by just a lot of action, and this last one was characterized by some amount of action, sort of hand wrist movement, and decent amount of electrodermal activation. And so I've given them these names of talk, engaged, action, and stress. And essentially what I try to do is re-represent the student's sequence, the student's sequence of data using these specific clusters. And interestingly, when I do that and then cluster those sequence of clusters, I end up finding a lot of similarity between the principle-based reason condition students, and this is even controlling for, or really leaving out their partner, because one thing you might say is that 2 people working together, they're more likely to mimic each other's behavior. So even when you control for the fact that you really sort of take their partner out of play, what I ended up finding is most of the students in the principle-based reason condition had a sequence of actions when they were broken down into these prototypical multimodal states, had a sequence of actions that was most similar to the other principle-based reason condition participants. And most of the example-based reason condition participants were the same in that they also were most similar to others in the example-based reason condition. The last thing I'm going to mention here is this high-level fusion. And high-level fusion is sort of this idea of you have this data in the case of audio, gesture, and electrodermal activation, and you're essentially passing it through sort of a classifier first. You're quantifying. You're taking the raw data, and now you're essentially quantifying it as, in this case, high, medium, or low. And then you also have this sort of interpretation of the gesture data, what it is. And motivation, one of the motivations for these is thinking about the importance of talking and gesturing. So you've got the deictic and iconic gestures. So here we have the data. So essentially what it is, it's taking this data fused with what are hand-labeled, these are essentially hand-labeled gestures. So it's me looking at the data and saying, well, okay, the action that the student just took was a planning action. The action that they just took was an evaluation action, an adjust, a nothing, or a revert action. And I'll essentially do the same thing I've done with the other analyses. Well, I'll take that data and I will again try to cluster it to sort of identify these prototypical states. And and then look at comparisons across different groups. Here are just the representation of what those different states are. None of them bear a lot of similarity to the ones I showed you earlier. But interestingly, when you look at how well it actually works at distinguishing between principle-based and example-based, it works really, really poorly. So you're seeing that, I mean, in a given grouping in terms of looking at similarity between participants' actions, here you have almost like an equal mix of principle-based and example-based in this sort of cluster, and in this other cluster, again, almost equal grouping. But what is really interesting for it is that it showed me different gestural enactments. So what it said was that when a student was building, so to speak, the way that they would enact a build in the principle-based condition was qualitatively different than the way a student may have enacted that build within an example-based reasoning condition. Maybe they use more gross movements in what they were doing, or maybe they enacted that build and they had more discussion, they had more conversation, or had more stress. So essentially that's sort of what I got out of this particular analysis of when I merged together the sort of the raw data with the sort of hand-labeled data. So just to highlight those, so naive, sort of this, what I did is more, I'd say it's more exploratory. You kind of push everything into a single data point, low level, and then sort of high level. And the last thing I'll mention is, and I kind of motivated this some earlier, one of the things that happens with this multimodal data is you kind of have to figure out at what level you want to try to, you want to really try to distill an action. And I mentioned engagement as one of these, right? You can be looking for the presence of engagement, which is to say, is this, and I really position this as like an or statement, right? Within a given context, it's audio or video or gesture or biosensor. The presence of any one of those things is an indicator of engagement. Versus a context where you're looking for a specific type of engagement. So let's say you're looking for audio in the presence of gesturing and biosensoring, which is going to be different than having no audio, having no gesture, and just biosensor. And so when you're making these sorts of decisions around how you want to analyze your data, you kind of want to be specific. And in this case, it's, am I looking for some kind of engagement, like them demonstrating interactivity with the task, or are there specific classes of engagement, specific engagement types that I'm trying to look at? OK, interest of time, let me.
Marcelo?
Yes?
So when you use the term engagement, it's a technical use, right? In some literature, you say engagement, one thinks of, is a child engaged as if it's something affective or interest. But for you, engagement is any aspect of interaction with.
Well, and so more so what I'm saying is that depending on how the researcher defines it. Yeah. So in some instances, a researcher may define it as anything. It could be affective, it could be cognitive, it could be physical, it could be whatever. And so in some instances, they may be thinking about, really, is the student doing something with the task in this moment? Versus in other instances, what they might be looking for is certain types of engagement. So in this case, I'd say certain type of a multimodal engagement that is characterized by someone being up, active, and verbalizing within that context. Versus another type of engagement that could really just be maybe you'd say like a cognitive engagement based on biosensor data that would suggest that they have cognitive load, or maybe pupil dilation as a way for them being mentally engaged within the task. So just as people are thinking about the constructs that they're working with, they kind of be intentional around how they're trying to operationalize those contexts based on the data that they have. Because that ends up being one of the decisions that you end up having to make when you're trying to analyze the data. But that I'm not going with one. I'm staying agnostic, just not going with one or the other. So in the interesting time, I'm going to skip to one last piece, which is really around segmentation. And so the last thing I'm really going to say about this multimodal data is just that we oftentimes think about it as a means to analyze our data. Like I'm going to use that as the basis for my analysis, right? I'm also going to try to suggest you can also perhaps, and this is something I've done in the past, is use it for segmentation. And so to give you a high-level picture of this, within the data that I showed you guys earlier, the ways that I segmented my data, the ways that I would say, okay, I'm going to take time step 0 through 100, or time step 100 through 105, was based on when the students tested their design. So I tried to have this very semantic interpretation of the data segmentation. And so this specific command, evaluate, anytime I came across this evaluate, I would basically say that's the end of a specific chunk of data. And to put that in concrete terms, it looked like this. So if I have a sequence of codes, nothing, plan, evaluate, this would basically say, all right, nothing in plan is going to be one chunk, realize, revert, and realize again, that's a sort of separate chunk. So I have these semantic interpretations for how I'm segmenting my data. I have these aligned with all my other modalities, so I'll do the same thing within those other modalities based on the time step. But what I recently did, and I guess a couple years ago did, was found a way to actually use facial expression information or head pose information as the way for automatically segmenting my data. So instead of having to base it on me hand labeling every time they tested, I could say, let me look for a change in head pose as a way for saying the student has sort of ended one phase, so to speak, and started a sort of a new phase. And so concretely that looks like this. Let's say I have this data. I will come down here and I'll say, okay, this pose is the same, this pose is the same, this pose is the same. This pose is different. So I'm going to group this as sort of one chunk, and then I'm going to analyze the rest of this together. So this is just to say that one way to think about using the multimodal data does not necessarily have to be in the sort of the substance of the analysis. It can actually be as a tool that you're actually using to discretize your data into these different chunks to kind of come up with these semantic representations. And what I actually show in this specific paper is that when I did it this way, it actually worked better than either the automated, fully automated way where I just break things up into 10-second chunks. Go ahead.
In practice, what does that change in pose look like?
Change in pose. So, sorry, yeah. This is looking at changes in either the first variable corresponds to left, right, and the other one corresponds up, down. But it is also positionally invariant, which means that it's really looking at changes either the student engaging the material in front of them or the student engaging their participant. So what it's picking up on is, okay, in this section, I was engaging my colleague. I was engaging my peer, my collaborator. And in this section, when I have this sort of change in sign, it's okay, I've now gone, I've returned to now engaging my material. So go ahead.
What are the units there?
So the units of this specific measure are based on a, let me show you this last slide. So what this constrained localized neural field is doing is picking up on these facial landmarks, and essentially what it is giving you is an estimate of the degree at which someone's head is turned. And I've just found a way to sort of normalize that into something that is looking positive left, positive right. So it really...
But is it continuous?
Yes. So yeah, that's the last thing I'll say is just that, so when I use this approach, it actually simplified my analysis in terms of I didn't have to go back and hand label all those things. It provided a semantic segmentation, but the neat thing too was that it actually gave me more fine-grained segments than what I actually got with my human coding. And so it's sort of this mix between what you get from a fully automated approach, which will oftentimes break things down into very, very small chunks, and what you get when it's more human coded and you end up having these relatively large chunks. So yeah, with the given time, let me... We're okay on time? Okay, the other super fast thing I want to mention is a slightly different approach, right? So this was, let me take the multimodal data and let me essentially let the algorithm analyze it for me. And from that kind of interpret things. The other approach that I've used within my data is something slightly different, which is where I'll use the multimodal data to start with. I'll let that multimodal data help me identify these sorts of multimodal states once again. I will then sort of correlate those multimodal states with a specific dependent variable. Let's say in this case I had post-test, like gain scores from pre-test to post-test. And then I really let that information try to help me then tell me sort of what are relevant video segments that I'm going to go back and human code. So in a sense, it's saying I kind of know what I want to look for. I'm really looking for differences in test scores. Now, what are the features that seem to correlate with those differences in test scores? And now that I know what those features are, show me where those chunks of video are. And so that's a approach I used on another data set not too long ago. And once I actually get to the point of analyzing, oh, that was the wrong slide. Once I get to the point of analyzing the data, I'll actually go back to ways that I've used beforehand. So I have these now specific chunks of data that I'm looking at that have been sort of picked out for me. And then I will go back and human code them. I will go back and using the same coding scheme I used beforehand, sort of break down what's happening within that given segment of video and start to then sort of try to make sense of the specific clusters that I maybe had beforehand and how those end up correlating with these codes that I had developed. And those codes, they sort of tie together with this very simple decision tree that I developed, where it sort of will walk you through these sort of decision boundaries around students who either performed well on an activity or sorry, they were below or above threshold. And so it started to be a way for me to start to make sense of the data, start to make sense of what seemed to be salient in terms of students' learning processes through this given collaborative activity. And again, putting it in context of codes that I had actually previously used within my work. So to conclude, there's two things I'm going to point you guys to. I mentioned the OpenPose platform. I'm also doing work on developing another sort of open source tool that people can utilize to collect audio data in conjunction with video data and any number of other things. This is a respeaker. This is a 4-microphone array connected to a Raspberry Pi. We have another version of this that's just there's a standalone respeaker. But what we're really building into this is a number of capabilities around identifying, so speaker diarization, figuring out who is the one who's talking at a given time, speech recognition, picking up on specific keywords, and then also incorporating in some of that open pose. So open pose is the thing that's giving you skeletal tracking, people's body pose from the video, as well as some facial recognition to try to really come up with a way to sort of characterize or capture these sort of multimodal states. And really the goal of having a platform like this is, one, to make it more easily scalable, take it outside of the laboratory and take it into more classrooms. But it's also around trying to do things in more real time. And there's a colleague of mine at NYU who's been using a similar platform to provide real-time information to students as they're practicing presentations. So it's a very simple context, I think, but what it essentially provides is a camera, a microphone, and the camera is connected to Raspberry Pi, and it does that open pose tracking. So one of the things they'll look at is the presenter's body positioning. Are they sort of slouched over? Are they sort of hands crossed? Where is their gaze? Are they paying attention to the audience, or are they sort of standing looking at the screen? And also looks at things like how much they're projecting their voice, the overall voice quality, the change in pitch and change in tone. Which I mention this here because I think it gets at some of the idea of thinking about real-time feedback, thinking about taking this data and introducing it in such a way that I think the DOOR system does. Let's provide this real-time feedback to the participant, which I will say within the multimodal learning analytics space is not something that's happened a lot. A lot of what's happened is we're going to do post-hoc analysis on this data and not provide people with sort of the real-time insights that we're gathering. So the concluding remarks are, there's lots of stuff you can do with the data. One thing I really should emphasize is segmentation. That actually matters a lot in terms of how you're analyzing your data. There's a very important element of theory. So theory plays a very big part in how you collect your data as well as how you analyze it. Feature fusion sometimes requires downsampling, and there's various ways to think about fusing your data. And then lastly, to not forget that a given data stream can be split in various ways, rejoined. There's lots of sort of combinations of things that you can do with your data. I think I've tried to mention too that some of this is about seeing the unseen. And one thing I won't go into length about, but one of the other approaches they use in multimodal data analytics, multimodal learning analytics, is hand coding a data set and then passing that hand coded data through a machine learning algorithm to allow it to help us sort of identify different patterns that we may not be able to see because they're so high frequency or they're hard for us to reason through. But I think in many ways the multimodal learning analytics can be a way to help you see the unseen. Related to this idea of a human-computer data analysis. So it's working together along the spectrum from fully automated to fully human to just human, thinking about different points along that spectrum where you feel like your work is going to sort of be most heavily benefited. And then lastly, which is something I mentioned earlier, the distinction between doing multimodal learning analytics work in school versus doing multimodal learning analytics work in the laboratory. I think there's a lot of opportunities to use this kind of work to explore and expand upon new theories or sort of new conjectures around learning. But then there's also this challenge of thinking about how do you deploy this multimodal work in schools in such a way that is going to be beneficial for instruction, beneficial for learning, realizing that schools are not necessarily laboratories, though sometimes we try to treat them that way. Okay, with that, I will conclude. Thank you, guys.
All right, I'll start. So why start with segmentation? It seems that you have a bunch of time series and you're growing those out immediately and going to segmentation and summary statistics rather than the kinds of things that my little coordination dynamics posse here might suggest. There's a lot of richness to be had in the continuous time series at the start.
No, and I don't like, so the naive fusion of taking the data and merging it all down into this like mean value for the entire data set is not something I actually normally do. But from the computer science side, that's often, I'd say that's oftentimes the starting point. Let's explore this data, let's mash it down into something that is very, very discrete and very like summary. But
sounds like the opposite of explore.
Well, I'd say that I will say within a lot of the multiple learning analytics work that has been explored, that's sort of where people have started from. They kind of say, okay, this is the simplest thing I can do. Do I get a signal here, or is this all just noise? Now, oftentimes, it is just noise. And that's when they start to go into, I think, somewhat more complex ways for trying to analyze the data. But for me, around segmentation, part of the reason to do it is because I feel like within many learning contexts, you end up with these distinct chunks of sort of types of action. So even in my study, right, the students start off, they're doing a pretest. After the pretest, they are participating in a given intervention. After the intervention, they're doing like a design test. So even just the process of saying, let me differentiate the data from the pretest portion to the data from the intervention, from the data from the task, and realize that the objective of each one of those actual activities is different. And so that's I'd say one of the reasons to do the segmentation is realizing that the actual objective of each one of those different portions is different. Breaking it down to the actual task, though, it's really just to have these sort of discrete units to kind of look at. To say, from this point, from point A to point B, the student had this objective. What are the actions that they took to complete that objective? Now from point B to C, maybe they have a different objective. And so that's, for me, one of the reasons to go about trying to segment the data, because it almost has like these natural distinctions between, or I'd say the students might even interpret differently their objectives during those different segments.
But there are time series analyses in which those segments would emerge. So rather than being dictated, and there may be something interesting around the transition from one segment to the next that you're missing because you're just separating this chunk from that chunk. So something like a multifractal wavelet analysis, you get the divisions actually emerge, and you can see periods of confusion or periods of cooperation.
No, I mean, I think that's definitely a possibility. I think just many cases we just started from simplest to go up to sort of most complex, and to think about the things that we can most easily sort of interpret and make sense of. But I think that's definitely true. I think really staying true to the time series, I think that is definitely a valid way for trying to do the sort of data analysis.
Sort of related to that, as you were talking, Marcelo, I was trying to sort of think how these different approaches might link together. In your case, you're trying to sort of extract something relevant based on your machine learning algorithm or whatever. It's interesting that the pose data, it's when there's a sort of qualitative change, that's when you can see things that seem to be relevant. From an experimental point of view, one would ask, what conditions can you create so that certain patterns might emerge, right? And that would be a complementary strategy to what you seem to be doing. Is to say, could you actually set up experimental situations where you know what conditions you're creating so that you could identify what the relevant patterns are? And I don't know if that would be part of your agenda or not, but that would be, so you've got actually two approaches. One is sort of this big data kind of approach and seeing whether you can extract patterns. That was a little bit like my ballet dancer yesterday. And the other then is to actually go in and see, what are the control parameters here? There's no order parameter without a control parameter here. And the control parameters are really creating the conditions for certain patterns to emerge.
And I think that is that sort of, I'd say that's a lot of what motivated to try to do this work, is that in sort of my thinking about education research, it's oftentimes we have a pre-test, we have a post-test, and it's not till the post-test that you really have a sense of whether or not this happened or not. And so what you really want to have is these sort of indicators along the way that lets you know whether or not this is going in the right direction or not. And then, as you sort of stated it, is to also be able to provide these interventions such that students can be directed or sort of be nudged in the direction of moving towards the direction that you're trying to get them to go. So I think that's absolutely the case. Oh, Anna. Either one. We'll let you guys duel it out.
Can you say a bit more about this gesture co-production? Is it just a correlation of coordinates gestures from two people?
In this case, yeah, it's really just looking at two people physically interacting with the activity at the same time. There's other work that looks more at the synchrony of gesture. The synchrony, the ways that which two people may be touching the same piece of the activity, touching the same materials at the same time, or, as I said, enacting the same types of body poses, the same types of body positions.
Can you go a bit more to the operational level? What kind of data from it?
So from that data, and this is a paper by a colleague, Bertrand Schneider, where he's looking at essentially pairs of people, and he will essentially try to construct a 3D representation of the participant based on the skeletal tracking data, and then look at similarities between, so I mean, you can imagine a sort of full body skeleton of each participant, and then looking at the extent to which the actions that they're taking are mirroring one another. The actions that they're in, or you can even think about how ones might lag behind the other. Because there's a lot of work in sort of collaboration that looks at convergence of sort of behavior, people mimicking the other. So that really, the way he analyzed that was actually based on the sort of three-dimensional skeletal tracking data.
And skeleton will become a number of set of vectors, I guess.
Yeah, skeleton becomes a set of vectors. And so yeah, he'll use that, and with the connect, I want to say you're getting like a 30-dimensional vector or something like that, or 36-dimensional vector that's representing the skeleton, and then doing a comparison between the two participants. You had a question up here.
There's a lot of interest in the physical activity world using actograph or just a single accelerometer to monitor people's physical activity during the day. In fact, during the night, in fact, for weeks or days on end. And initially, I think most of that was on the amount of activity. So that's pretty standard to sum up the acceleration values and get a mean, like you suggested with some of the work. But the more interesting is now breaking it down into identifying the activities that the person's actually doing from a single 3D accelerometer. And that's still, I think, in the developmental phase, but the claim is that that's doable. I don't know whether you're aware as to how good or bad that is. That's one thing I'm always interested in. It seems a long way to go from a single 3D accelerometer to, you might be able to identify standing from running or some of the more fundamental activities, but you get beyond that, it seems like you need some additional inputs like these other devices that you introduced to us, or introduced to me anyway.
So that has been my take. I mean, I have seen the work on people using smartphone. You have a smartphone and that'll detect you standing, sitting, walking, jumping, or what have you. I, for example, look to, so like I said, with all this video that I've analyzed using computational approaches, I've also sat down and watched and coded all of those videos also. And so one of the things I really wanted to do was, well, let me actually see the extent to which the codes that I've developed can be predicted based on even the hand-wrist movement that I've collected from the skeletal tracking data. When I try to build those classifiers, it comes up with just noise. It's not at all predictive. So trying to use a single accelerometer to really pick up on complex actions, I think can be tough. Now I will say there's another colleague out at NYU, Yoav Bergner. He's been using, and actually there's a PhD student in I think University of Sydney also he's been collaborating with. They've been using accelerometer data as well as OpenPose to study dance movement. And so there, I mean, it's rhythmic, right? You're really looking for this sort of frequency and seeing the extent to which the way that the body is moving and really looking at hip position and seeing to the extent to which that is matching up with the frequency of the audio of the song that's being played. So there are some instances where there are metrics that I think you can extract from this single three-dimensional accelerometer data that can then help you interpret or see how well someone is doing a certain activity. But the extent to which you're able to pick up on things like, I don't know, like throwing a baseball or moving your hands up and down just from accelerometer data attached to your hip, I'm not yet convinced of that one.
Thank you.
Go ahead, Dor.
I have actually 3 questions or comments, but one of them is really easy. So, as these new ideas around learning analytics are evolving, I know that there are different terms out there for characterizing the nature of the work, and so sometimes we hear people talking about learning analytics and sometimes about data mining. Are these what is being used now, and are they synonymous?
Both.
One inclusive of the other? It's like the Monty Python thing, the 2 groups.
So I'm sure Zach will also have a take on this. I mean, there's been 2 sort of communities that have developed. There's the educational data mining community that, in my opinion, I think a lot of that developed out of the work around in cognitive or intelligent tutoring systems. And then I think there's another group of work that came up more so out of MOOCs. And I think the people doing work on MOOCs and the people doing work in educational data mining, one saw themselves as perhaps being closer to learning systems, and the others saw themselves more being close to like learning technology. And so I think in many respects, I think the groups there's a lot of overlap between the groups now. But I don't know, Zach, what's your take?
That sounds, about right. When I come up with a statement of in what field am I contributing?
Depends who you're talking to.
No, I'll say AI in education is another
Another one.
AI in education.
Yeah. AI in education has the larger society. That's more story. It goes back to the 70s when it was formed. And I was saying AI in education and learning analytics are all coming to think of themselves as under learning sciences, but a more computational branch of it.
So you see, it wasn't such an easy answer after all, Dor.
My second question is about, you mentioned interest in real-time analytics.
Yeah.
And I wondered what you can tell us about work of, we hear this word about dashboards, teachers having dashboards, so they can have in real time information about their students, which is something probably if you're just working with a person, you pick these things up naturalistically, you don't even know that you're doing that. But because they're remote and because there are many, and because they are working each on their own project or they're at a different place on some computer-based task, you want to get some sense of that. Where I mean, that's very kind of Orwellian, right, on the one hand, but on the other hand, not, in the sense that we're trying to, one teacher is trying to maximize their real-time relationship and work with so many students. So what's the future of that, or what are we talking about here?
So, I mean, the dashboard space is one that people also have sort of mixed viewpoints on. For me, I think it's about providing additional representations from which a teacher or a student can make sense of or reflect upon their learning experience. You know, I think about dashboards largely, you know, and because of Paulo, largely in sort of Makerspace, Fab Lab context, where you may not always get the sort of immediate feedback on your progress, on the quality of the design of your structure or your work, so to speak. And so if you have these means for both studying and documenting student development over the course of time as based on some sort of semi-automated means, that can be a useful tool even for the student to recognize, hey, I'm actually showing some progress here. I'm actually developing. I'm not just here playing around with sensors, or I'm actually accomplishing. I'm actually sort of achieving something, as it were. I think the other part where they come up is in work around classroom orchestration. So Pierre Dillenberg and Jeremy Rochelle talked a number of instances around how do you help support learners within a given learning space. And oftentimes what you really need is you need more content, you need more data from which to ensure that you are getting the right attentional cues into recognizing what are the needs of the people within your space. And so some of the idea around the real-time teacher dashboard, real-time teacher information, is to help direct individuals, help direct teacher towards opportunities to engage with and sort of support learners. But no, there's been a lot of work around dashboards and sort of people really trying to wrestle with what are the appropriate representations for this information. To what extent do we want to dictate what a given data point means? Do we simply provide the raw data? Do we provide our interpretation of that data? Do we provide our prediction of what this student is going, or where the student is going to go based on their past data? So there's just these discussions around what is the appropriate position and what's the sort of appropriate level of intervention or even level of automation that should come as a result of this data. That I think is still sort of a very large sort of open question where some people say, well, you know what, we have this prediction, let's tell them the prediction that this one's going to fail and just give that to them, versus, well, let's surface some information to the instructor so the instructor can interpret that information as they see fit and in the context of the classroom, in the context of what they've observed, and then let them decide how to use that content.
And of course, I think one point is important, that is to what extent the report which is taken from the result of this, let's say, data can be attributed to the learning. maybe they're not so accurate, and they guide me in a way which is not exactly in line with the learning which I'm after. This is, I think, one of the challenges.
I think it's one of the challenges. I think it's also why, in many cases, like I said, the multimodal learning analytics work has not necessarily made its way heavily into practice, because you want to be certain. You want to be certain about the data that you're presenting and really the interpretations of that data. And that's why I think a lot of times now people are just sort of hedging towards, let me present you with the data and let you draw your own interpretation from the data, as opposed to, I'm going to push this through a classifier that says you're going to end up failing this class, or you're going to end up succeeding in this class. Is that a hand?
Let's thank Marcelo.
Thank you, guys. Yeah.